Effective Kotlin Item 15. Properties should represent a state, not a behavior. Kotlin properties look similar to Java fields, but they actually represent a different concept. In Kotlin, we declare a property, for example, a mutable name of a nullable string type, while in Java, we declare a field of a similar shape. Even though they can be used the same way to hold data, we need to remember that properties have many more capabilities. The first of which is the fact that they can always have custom setters and getters. For instance, we can define a name property whose getter returns the value in uppercase, and whose setter assigns the new value only when it is not null or blank. In such a setter and getter, we are using the field identifier. This is a reference to the backing field, which lets us hold data in this property. Such backing fields are generated by default because the default implementations of setters and getters use them. We can also implement custom accessors that do not use them. In this case, the property will not have a field at all. For instance, a Kotlin property can be defined using only a getter for a read-only val property, like a first-name property whose getter simply joins the name and the surname. For a read-write var property, we can make a property by defining a getter and a setter. Such properties are known as derived properties, and they are not uncommon. They are the main reason why all properties in Kotlin are encapsulated by default. Just imagine that you have to hold a date in your object, and you use date from the Java standard library. Then, at some point for some reason, the class cannot store the property of this type anymore, perhaps because of a serialization issue. In that case, you can keep the date as a property backed by a millis value, where the getter creates a date from the milliseconds, and the setter stores the time of the given value. Properties do not need fields. Rather, they conceptually represent accessors, a getter for a val, and a getter and a setter for a var. This is why we can define them in interfaces. For example, a person interface can declare a name property of type string. This means that this interface promises to have a getter. We can also override properties, like overriding the answer property in a subclass. For the same reason, we can delegate properties, for example, by declaring a database property by lazy that connects to the database only when it is first used. And because properties are essentially functions, we can make extension properties as well, like a preferences extension property on context that returns the default shared preferences. As you can see, properties represent accessors, not fields. This way, they can be used instead of some functions, but we should be careful what we use them for. Properties should not be used to represent algorithmic behavior. For example, imagine a sum extension property on a tree of int, whose getter recursively adds the values of all leaves and nodes. Here, the sum property iterates over all elements, representing algorithmic behavior. So this property is misleading. Finding the answer can be computationally heavy for big collections, which is not expected for a getter. This should be a function, not a property. The general rule is that we should use properties only to represent or set a state, and no other logic should be involved. A useful heuristic to decide if something should be a property is, if I define this property as a function, would I prefix it with get or set? If not, it should probably not be a property. More concretely, here are the most typical situations when we should use functions instead of properties. An operation is computationally expensive or has computational complexity higher than O of 1. A user does not expect using a property to be expensive. An operation throws an exception. A user does not expect that a property getter or setter can throw an exception. It involves business logic, that is, how the application acts. When we read code, we do not expect a property to do anything more than simple actions like logging, notifying listeners, or updating a bound element. It is not deterministic. Calling a getter should not change a state, and calling a setter twice in succession should produce the same result, unless the object has been modified in another thread. It is a conversion, such as int dot to double. It is a matter of convention that conversions are methods. Using a property would seem like referencing some part of the state that is wrapped over by the object. And finally, getters should not change property state. We expect to be able to use getters freely without worrying about property state modifications. For instance, calculating the sum of some elements requires iterating over all of them, which is behavior, not a state, and has linear complexity. Therefore, it should not be a property and is defined in the standard library as a function, which is why we write something like the sum of a range as a function call. On the other hand, to get and set a state, we use properties in Kotlin, and we should not involve functions unless there is a good reason. So instead of writing a class with a private name field exposed through a genetically and set state method as you would in Java, we simply declare a public name property. We use properties to represent and set state. If you need to modify them later, use custom getters and setters. A simple rule of thumb is that a property describes and sets a state, while a function describes a behavior. This was an item from the book Effective Kotlin, which covers best practices and philosophy of good quality programming in Kotlin. It covers all important aspects of programming, such as safety, readability, reusability, performance, abstraction, and class design. You can find it on LeanPub or Amazon. Its author, Marcin Muscala, offers consultations, workshops, and courses. All links in the description below. I hope you enjoyed it. Cheers!